Okay, sir, no problem. Thank
But
you.
any YouTube streaming will be available immediately.
Oh, okay, sir, then it's fine.
So streaming started, sir.
Yeah. So we'll just in another 2 minutes we'll start.
Okay, sir.
Sir, shall I initiate recording, sir?
Okay. Okay, we'll start now.
Yes.
Good evening to one and all. On behalf of IEEE Computer Society, ACM, and CSI Chennai chapter, I extend a warm welcome to our today's speaker, Dr. S.N. Deepa, my colleagues from organizing units of this webinar, and all the participants joined this webinar through Google Meet platform and YouTube streaming. My special welcome and thanks to Mr. Deepak Saxena and his team members from Wiley, India, for facilitating this talk by Dr. Deepa and also offering a chapter from her book, The Principles of Soft Computing, to the participants of this webinar. Coming to soft computing, it refers to a collection of computational techniques in computer science, artificial intelligence, machine learning, and some engineering disciplines which attempt to study, model, and analyze very complex phenomena which are more conventional, for which more conventional methods have not yielded low-cost, analytic, and complete solutions. Earlier, computational approaches could model and precisely analyze only relatively simple systems. More complex systems arising in biology, medicine, humanities, management sciences, and similar fields often remained intractable to conventional mathematical and analytical methods. Soft computing differs from conventional, what is normally called as hard computing, in that Unlike hard computing, it is tolerant of imprecision and uncertainty, partial truth and approximation. At this juncture, the principal constituents of soft computing are fuzzy systems, neural networks, evolutionary computing, machine learning, and probabilistic reasoning. Soft computing is likely to play an important role in science and engineering, but eventually its influence may extend much farther. In many ways, soft computing represents a significant paradigm shift in the aims of computing, a shift which reflects the fact that human mind, unlike present-day computers, possesses a remarkable ability to store and process information which is pervasively imprecise, uncertain, and lacking categoricity. Today, in our presentation, Dr. Deepa will demystify the world of soft computing. Coming to the speaker, now it is my pleasure to formally introduce Dr. Deepa. Dr. Deepa has completed her BE in Electrical and Electronics Engineering from Government College of Technology, Coimbatore, and ME in Control Systems from PhD College of Technology. She had completed her PhD in Electrical Engineering in 2008 from PhD College of Technology under Anna University. Dr. Deepa has been academically brilliant. She is a gold medalist in her BE and the recipient of Best Outgoing Student Award in her MBA. She has received National Award from Indian Society of Technical Education and L&T for her MBA thesis work. Her research was completely funded by All India Council of Technical Education under the scheme National Doctoral Fellowship from the year 2006 to 2008. Dr. Deepa, who had a long stint at Anna University, Coimbatore, now currently is an associate professor in the Department of Electrical Engineering at National Institute of Technology, Arunachal, Pradesh. She has 17 years of teaching and research experience and has published 10 books with national and international publishers, 105 international journal papers, 11 national journal papers, and 57 papers in national and international conferences. She has also filed one patent for credit. Under her supervision, 22 scholars have completed their PhD program. Dr. Deepa's research areas include linear and nonlinear control system design and analysis, modeling and simulation, soft computing, evolutionary strategies, and adaptive control systems. With this brief introduction on the subject of today's talk, let me invite Dr. Deepa to take over and enlighten us on soft computing. Over to Dr. Deepa.
Yes. So, most respected HR Mohan sir, Subramaniam sir, who was the past chair of the IEEE Society, Akila, in absentia, Professor Dr. Sakthivel of Anna University, Dr. Priya Vijay, Vice Chairman of IEEE, and all my Deepak Saxena sir from Wiley, and my dear participants. A very good evening to one and all present here. It is my honor and privilege to deliver this webinar. So with respect to my book, this title, so it was my title with Wiley was Principles of Soft Computing, and now currently it is with the 3rd edition. So with respect to this, I'm happy that a chapter is being given to all the participants. Okay, so I'd like to thank Wiley for this. So now to start with soft computing. See, currently, before going into what is soft computing. Okay, so currently we speak on some terminologies. They call it as machine learning. They call it as computational intelligence. They call it as expert systems. They call it as artificial intelligence. They call it as soft computing. They call it as evolutionary strategies, evolutionary computation, and so on. Why robotics is occupying? So if you see in Japanese, so what is happening in Japanese, so all surgeries are being done by robots. So robots has hand, robots has vision. Only if it has vision, it will be able to do the surgery. And robots should have decision making capability. So during surgery, which part has to be taken, which part has to be removed, what is the level of ECG which has to be maintained, etc. So many things are there. This is capable only by medical physicians or medical surgeons. But how in Japan or wherever now the trend of doing microsurgeries or arthritis or arthroscopy surgeries are being done by robots, you're modeling it. So humans, so if you see the slide, I've just given a brain, human brain. Okay, so we have our central nervous system. Human, see, everything is based soft computing. Why it is not hard computing? Hard computing is called as traditional methods. So everyone will be pursuing research, or you have completed your research, or you will be in the scope of filing a patent. We go day by day, right? You want to improve yourself. You will be submitting many research proposals. Now will be more towards deep learning methods. So what is happening? We are more bothered our brain. So our brain cells, our central nervous system, our neurons, your cerebellum, medulla oblongata. So all those stuff. So why? Okay, so why? Because they tell soft computing by the word soft. They take humans are soft. Okay, so they take human machines. Machines are hard. A CNC machine is a hard machine. A PLC, a Siemens PLC, it is so S7400 or S7100. So it is hard. A lathe machine is a hard one. A pneumatic machine is a hard one. A textile machine is a hard one. An MRI scan machine, a biomedical related application instrument is a hard one. So they all use hard computing techniques. Because the topic is soft computing. Why? Before going into what, when, and how, I don't think I'll be able to touch that part. But why is very, very important. Why everyone speaks of artificial intelligence? Why soft computing? What is the need for soft computing is very important. If you know this, you will become excel in computational intelligence methods. Whatever. See, all the names are same. One same phenomenal characteristics, and the classifications are different. That's it. The classifications are going to be very different. So in the slide, if you see, I have shown a cockroach, I've shown a dog, and I've shown a human brain. So what is not in them is being possessed by the human brain, the capacity of the human brain. You should not underestimate the capacity of the human brain. So we have sixth sense. So either a dog or a cockroach don't have sixth sense, right? What is their daily life activity? An ant, an animal, any cockroach, hunting for food. Do we stand, humans, do we stand only for hunting of food? No. We search for something else apart from food. We search for something else, hunting for food. Okay, everyone get the food. We eat the food 3 times a day, 6 times a day if you have some gastric problems. Okay, so you're done with the food. No. Apart from, so a difference between the animal's lifestyle, an insect lifestyle, and a human lifestyle. So they are more only for hunting of food, and their search stops there. But our search, the human search does not stop only with the hunting for food. So when we go for search to the next level, when we are going for the search to the next level, so we use our brain. So if you see, you can Google and see who is using, how many percent of the neurons we are using. So we are using less than 1% actually. There is a ratio, okay? I don't remember that. So Einstein has used this much percent of the brain. Steve Jobs like that. So there is this much. How many brains, who has used how much portion of the brain? So with this immense capacity, the brain is capable of making values, making judgments, you have your own behavioral patterns, and you make your own structure. We have our own habitual features. We have our own habitual features. So a human brain. So what is soft computing? Before going into why, what is soft computing? Modeling every component, how a human thinks, how a human brain acts, how a human makes a decision, how is the human evolution carried out. How is the human evolution? See, evolution. When you said evolution, you can always remember Charles Darwin's theory of evolution, right? We can never forget Darwin's theory of evolution. So, human brain, human decision making, human evolution, that is soft computing, right? That is soft computing. So, what is soft computing? So, I said you model a human brain. Okay, they said when Ms. Shri Mohan sir said soft computing is fuzzy logic, soft computing is neural network, soft computing is evolutionary computing. Yes. So how human brain? You model another human brain. A human is going to model a human brain. Yes, it is a neural network. Human makes a decision. Okay, some decisions are going have to be made in a way thinking like humans, how humans think, how human arrives at a decision. Like that, if you're going to make decision, you have some rules, like, right? If it is like this, if it is cloudy, it will rain. If it is hot, you have to put on your AC. You have your rule base, if then rules. If he is like this, then I have to react like this. If my boss is like this, then I will go. If it does not rain in the evening, I will go to the mall. You have so many if then rules in our life. We have so many if then rules. If this if then rules, you are going to apply it for a application, it is fuzzy if then rules. It is fuzzy if then rules. So human brain, how human brain thinks, how human brain acts, how human brain learns, all this you model it. Neural computing, artificial neural networks, ordinary neural networks, machine learning models, all the same. Okay, with respect to classification, it differs. That's all. Now, human decision making. I make a decision making. I want to go for an evening shopping. Okay, then I say, so no. The cloud is like this. I don't want to go. So if it is like this, I will go. If it is not like this, if tomorrow it is not a holiday, I can take extra hours for the students. So if Saturday, Sunday is holiday, I will take the class on if then rules. So if then rules, how humans make a decision, you make a decision making, then that will be called as fuzzy systems. Okay, many things I will come into it in detail. But I'm telling the third one, evolution. You look tall, you look short, you look fair, you look brown complexion, you look dark, your hair is brown color, your hair is dark color, your nails are like this, your fingers are straight, your fingers are lengthy, your fingers are short, so etc. All evolution based on chromosomes. So we have 23 pairs of chromosomes embedded in us, and that chromosomes, so evolution, human evolution, how human evolve, how human, for example, when the evolution takes place now, so when the evolution process takes place, the prominent genes of your father and mother make you are based on their prominent genes. So evolution, so the one which gene enters and makes now, so that prominence is there, that is evolution process. So that human evolution process is modeled as evolutionary computation. So computational intelligent techniques or machine learning models are soft computing methods. Everything are fundamentally lying on how human brain learns, how humans make a decision making, how humans perform a evolutionary process. Why we require all these, why we require this type. Okay, so why we require all this type, if you see in this case, so always we require, what is our ultimate aim? So you can tell it me in chat box also. What is our in day-to-day life, in either engineering domain or even in science domain. So science technology, as it goes, no, science STEM, always they tell STEM, science technology engineering management. Now STEAM, what is STEAM? Science technology engineering agriculture and management, it is STEAM. So in all domains, whether it is science domain, technology domain, engineering domain, agriculture domain, management domain, what is our ultimate aim? Always we are more bothered on problem solving. Always we are more bothered on problem solving techniques, right? So ultimately we want to solve problems. We want, so however it is, so like this renewable energy side, or computer systems, if you see operating system side, or networks, wireless network side, if you see management like stock market side. Now if you see, because of the Ukraine Russia problem, the stock market has reduced. So stock market prediction I want to make. Okay, so I want to make stock market predictions. Okay, so there are science. So science, for example, in agriculture, this seed yields this much productiveness. So how much seeds if it planted, and if it is being done for this time, how much it will yield. So like this it is going on. So always our ultimate aim is to solve problems, right? So it is always, we want to give solutions to problems. We want to give solutions to problems. So if you see, when you want to give solutions to problems, if soft computing is not there, now you have to ask a question. If soft computing is not there, if computational intelligence, if robotics is not there, if artificial intelligence is not there, if expert system is not there, then what would have been there? They call it as traditional approaches. So if you see in papers or any magazines articles, they tell why you go for soft computing, because I want to replace traditional techniques. Hey, what is traditional techniques? What is traditional techniques, or what is conventional approaches? Why do you want to overcome the traditional approaches? Why do you want to replace? So now I want to ask you a question. Okay, so I will put forth it like this. So any system in the world, any system, so system means humans are systems, right? Human system, you always call it as human system, right? So we always call it as human system. So human system is made up of respiratory system, nervous system, excretory system, central nervous system, muscular system, your digestive system, your your respiratory system, your your cardiovascular system, and so on, reproductive system, and so on. So a system. So any system, let it be an engineering system, a hydraulic system, a pneumatic system, a biological system, a management system, everything will be called as a system. So this is a very big word, right? So system word. So the system is not running properly. The system is not set correctly. They call it as a system. So human system. So a system is made up of components, right? A human system. So if you see a cardiovascular system, you have your heart, you have your veins, you have your arteries, you have your all your vessels, blood vessels, etc. You have, and if you see your digestive system, you have your stomach, you have your internal intestine. So every system is made up of components, internal components. Respiratory system, you have your respiratory tract, you have your lungs, etc. Your central nervous system, you have your brain, you have your oblongata, then you have your spinal cord. So so now a hydraulic system, modeling how human system is there, how they model another system, a CNC system, a pneumatic system, a hydraulic system, a thermal system, an electrical system, or a power system. So how do they model a system? So a system is comprises of several components. Any system in the world will have input and output. Okay, remember, this is very, very important. Okay, so any system in the world, you consider any system. When I tell a system, you consider your own system which you are comfortable with, or you are carrying out your research. So any system in the world has input and output. No system in the world is there without input, and every system wants to deliver an output. So today from morning 1 a.m. till night, okay, so 12:59, okay, so PM. So till the night, okay, so what you have delivered the output at the end of the day, at the end of the 24 hours, what is the, so any system has to deliver an output. If that machine, if that washing machine is a system comprising of motor, everything, if it is not working properly, you condemn it. You don't deliver the output, okay, it got repaired. If air conditioner it's not working properly, yes, it is a system. If a refrigerator is not working, yeah, you condemn it. So every system has to deliver an output. Human system, what are the inputs? You have food for your energy, your clothes, etc. Fundamental needs. Apart from that, what is the inputs you have? You have knowledge inputs. You have what called as knowledge inputs. Where do you get the knowledge? From your gurus, from your teachers, your kindergarten teacher, your first standard teacher, your fifth standard teacher, your 10th standard teacher, your 12th, your BTech, your MTech, your PhD supervisors. You get it from books. Nowadays, you get it from internet sources, online materials. You get it from your WhatsApp. You get it from your Instas. You get it from web resources. So many knowledge inputs. You get it from your grandparents. You get it from your siblings, your brothers, sisters, your father. You get so many knowledge inputs. So many knowledge inputs. Where are you storing all those knowledge inputs? You are going to store all your knowledge inputs in a place called as brain. Okay, so your brain cells, your neurons. So you have always your neurons like this. Okay, so your human neurons. So okay, so it is like this. So with dendrite, soma, axon, cell body, nucleus, synapse, etc. Your human brain, all the knowledge inputs. So food is an input. You keep food aside. Okay, so we are going to model. I was telling traditional approaches. We have to go to what is traditional approaches. Why soft computing? The topic first itself is why soft computing. If I want to tell soft computing, why soft computing, I'm defining all these informations. So that is, I want to tell, it is not going to be one input. It is not going to be in one input. So always it is going to have multi inputs. So a system, so always it is going to have multi inputs. Always is going to give multi outputs. So you are so if you see your son, you are then a student, you are a brother, you are what to say, you are an employee, then you become a father, then you become a grandfather. You see, each one in office you deliver some output, in your home you deliver one output, to your father and mother you deliver an output. So how many outputs you are delivering? Multi outputs you are delivering. So always all the systems in real world, so either it is going to be human systems or either your systems, whichever you model na, so all these systems will be mini systems, so will be multi-input multi-output systems. So multi-input, whether there will be only one input. See, for example, there will be 1 lakh input and 1 lakh output. For example, an institution, so I have studied at PSG College of Technology. So it is a golden jubilee celebrated institute. For example, when the first year was started, how many students would have been there? 240 students. Second year, how many students? 480 students. Subsequently, as years goes on, the complexity of the data, student data, that is to be maintained in the institute goes on increasing. Anna University or NIT, whatever it, any system. Okay, if initially a company is started only with 10 employees, then it goes to 100 employees, then it goes to 1,000 employees. You need a separate HR department to look into the aspects of all the provident fund, etc., CPS or NPS of all the employees. No? So what happens? Data increases. So that is what I want to tell. So always what is going to be increases? Data increases. When data increases, the volume of data also increases. The complexity of the data also increases. So remember, this term is very, very important in soft computing methods. Complexity of the models, any system, human system. See, always you have to be linear, you have to be stable. So now in this forum, if someone is not stable, if they put on their microphones, put some music or songs and they disturb and it is unstable. It is not linear. Okay. Even though the complexity of the system increases, either it is traditional, Either it is hard computing, traditional methods or conventional methods are called as hard computing methods, and all the computational which operates based on human phenomenons, human decision making, human learning, how human gets trained, how humans have evolved, evolutionary process. Everything is called as soft computing. So when the complexity of the data increases, it is said that for some complex problems, hard computing or traditional methods will not give a solution. The traditional methods will not give a solution. So if this is not giving a solution, I'll tell you how it will not give a solution. If it is not giving a solution, then move to soft computing techniques. Okay, when for multi-input, multi-output systems, then it is not always single input, single output. I told you it is always not going to be single input. Any system in the world will have inputs and outputs. And any system in the world will not have only one input and one output. All the systems will have multiple inputs, and there will be multiple outputs. Okay, when multiple, it will be 1 lakh input if you take NASA, or if you take ISRO, a satellite, or don't want to go to ISRO, NASA, or a small, for example, a BSNL tower. A BSNL tower around 20 kilometers or 50 kilometers zone. If the tower is there, if you have a Wi-Fi connection, how many frequencies will be there? How many networks, how many home networks will be connected to each of them? How many networks will be connected? How many inputs it will have? How many outputs it will deliver? How many outputs if it will? A very fundamental example. What is a fundamental example? If you see flight, many would have traveled in flight. So an aircraft, basically. Okay, so an aircraft. Okay, so just take it to be aircraft, sorry. So what happens in the aircraft? So an aircraft, upward velocity, downward velocity, latitudes, longitudes, wind velocity, white petrol level, weight of the passengers, moisture content in the air, humidity in the air, etc., etc. What is happening? So many parameters will be there. You see, when you enter a flight, if slightly you turn and see, you see the control panel of the pilots which they have. We'll get, oh, what is this? Like that we'll feel, because so many parameters. So each latitude, each longitude, each altitude. So each latitude, longitude, altitude, where is it? It is going. So what is it when it is getting down? What is the speed of the engine level? See, you can know when it is going runway, it will be going in such a speed, and immediately the pilot, it will be released from the autopilot scheme, and the pilot will control it. And this, how many parameters will be there? Moisture content, humidity level. You take, once a flight craft is there, then they download all the data that we cannot even see the parameters. So we take inside, go inside, we sit, we sleep, we get out. You think of the parameters, thousands and thousands of parameters will be there. So it is governed by AI. It is an expert system, a neural modeling, a neural control modeling is there in the system. So I am telling complexity. Complexity of the problem is there. Why soft computing? So data. So now you are able to accept size of the data is getting increases day by day. So now you are able to accept size of the data gets increased year by year, decade by decade, it is increasing. And the complexity of the problem also, if it is a simple problem, okay, no problem. You solve with conventional techniques. I'll tell you what is conventional techniques. Simple, okay, it is simple, okay. For example, to make it simple, I'm asking you a question. So for example, x plus 2 is equal to 0. What is the answer? X plus 2 is equal to 0. What is the answer? Even if x plus 2 is equal to 0, anyone can unmute. Minus 2, yes. Pulikesi has said, Nirmala has said, Mari sir has said, Vaishnavi. Yes. So see here. So it is minus 2. X is equal to minus 2. Simple. Okay. So now I am asking you x squared plus 3x plus 2 equal to 0. Now what is the solution? It's an algebraic equation. X squared plus 3x plus 2. It's an algebraic equation. So now what is the solution? Now what is the solution? Yes, good. Nirmala has said. So it is, Rohini also has said. So it is x is equal to -1 and -2. Perfect. So now I am asking you, x cube plus 6x squared plus 11x plus 6 equal to 0. Okay, so x square, x cube, it's a cubic polynomial. Okay, it's a simple equation. X plus 2 equal to 0 is a simple equation. X squared plus 3x plus 2 equal to 0. It's an algebraic equation. X equal to -1 and -2. X cube plus 6x squared plus 11x plus 6 is a cubic polynomial. Now what are the roots? It's a cubic equation. Perfect. Now what are the roots? What is the value of x? Which standard have we calculated it? Now, what is the value of it? 3 roots. Yes, yes, Miss Nirmala, for example. Yes, Rohini has said -2, -1, -2, and -3. Okay, so now I go for x power 4, or I go for x power 10, or I go for x power 100 plus 5x power 99. I want you to find 100 roots is equal to 0. Now, how will you do it? The problem was simple. You were able to find a solution, right? X plus 2 is equal to 0. X squared plus 3x plus 2 is equal to 0. X cubed plus 11x, 6x squared plus 11x plus 6. Next, x power 4. Yeah, binomial theorem. Yes, even binomial theorem. What is the computational time it takes? And how for x power 100? Yes, Akila ma'am says mathematical complexity increases. So, see, and why all of a sudden, why? So, minus b plus or minus, for doing x squared plus 3x plus 2, we will use minus b plus or minus b squared plus 2ac. And suddenly, 11th standard, 12th standard, for your kids or for you, they started with differential equations. Yes or no? We started studying integration and differentiation. Yes or no? I'm coming to soft computing. Do not worry why this madam is handling maths. This is highly important. If you want to know traditional, why soft computing, you should know this. Without your fundamentals, you cannot go to soft computing. So why all of a sudden we are going for integration and differentiation? You can stop either with analytical geometry, or you can either stop it with polynomial equations, and you can use only binomial theorems. Why all of a sudden you want to study differentiation and integration? Any answers, my dear participants? Continuous. Yes. Why continuous? Yes, Pulikezi is correct. Continuous. That word is very important. Continuous. Why integration and differentiation? Dynamics. Yes, Kavita Mitra, dynamics. But the most important word is time. Everything varies with respect to time. Everything varies with respect to time. So you were in first standard, you were in second standard, you were in fifth, you were in 10th, you were in 12th, you were in BTech, MTech, or your BS, MS, or you are in PhD, you are a faculty. So you're here years. So for example, you're born in 1980s, 80 kids, or 1990 kids, for example, 1990, 2000, 2010, now 2020. So all those born in 1990 will be 40 years. So you started to study fifth at your 5 years. So whether the curve is increasing or the curve is decreasing for you, whether for you as time varies, your performance or whatever it is, you want it to increase or you want it to decrease? We want it to increase, right? So decreasing. Why, Akila ma'am? As years goes on, our performance goes on increasing, right? So always our performance goes on increasing. So everything varies with respect. So earlier, no, we had we purchased it for few price. Okay, for example, petrol diesel rate. Yes, I remember when I started driving my two-wheeler and I put petrol. I think I remember it was 32 rupees per liter. Okay, so now what has happened? So it is touching more than 90, right? So what happens? Everything varies with respect to time. Everything. If it is efficiency, if it is a metric efficiency, what is efficiency? Always efficiency is output by input. Output by input is efficiency. A motor has to be efficient. If that motor is not efficient, in a washing machine, the motor will not rotate. If the motor is not rotating, the cloths will not rotate. Okay? In a fuzzy based washing machine also. Efficiency, pump. A pump has to be efficient. Why a pump has to be efficient? Because then only it will, wherever, if it is a submersible pump or it is a overtank pump or whatever it is, it has to take water to the top level, and it has to be efficient. If it is not efficient, the buyer will not buy your product. And you want to be efficient. Okay, so you want to be efficient, you want your H index to be that, you want to be your everything, you want your performance to be efficient, and always efficiency you want increasing. Always error has to be decreasing. Error has to be decreasing. So now, why integration and differentiation? Time, na? So everything varies with respect to time, whether algebraic equations or cubic equations or simple equation does not vary with time. But once it has to be like everything varies with respect to time, hence you studied your d squared x by dt squared, d squared x by dt squared. You studied 5 dx by dt. You studied plus 7x is equal to u of t. Okay, see why x is a parameter. This parameter may be a petrol value. D squared x by dt squared. Petrol, x may be a petrol parameter. Fuel value. So with respect to time, d squared x dt. So x dot. Okay, so dx by dt, where x may be any parameter. It might be a seed for a root or a stock market value. Anything varies. So with respect to minute by minute, second by second, they'll be calculating the stock market. If you see BSE and index, all it will be varying. So hence everything varies with respect to time. So hence you study on you study on your integration and differentiation to operate with respect to time. Everything, see, just don't operate monotonically. Don't operate anything monotonically. You operate everything in a very clear, lucid manner with respect to time. So today I want to do this. At the end of year 2022, I want to have completed this work. I want to have done with a book. Yes, I want to have some target with respect to time. But due to some of your situations, it might vary, right? So how do they, when it varies with respect to time, what happens? Yeah. So we represent it by means of differential equations. So we study now mathematics. Okay, so any engineering domain, some science domain, some might study. Physics people all might know differential equations. So this differential equations, so as one sir said, it is continuous, right? It is continuous. It is continuously with respect to time, it will be varying. And you have heard of digital watches, right? So you have heard of digital watches. So it will be like this. So it will be like this, na? So you have seen these digital watches. So now this will operate. So have you seen like this, na? So whenever, so your regular watch, na, your regular clock will be like this. Okay, you have your needles like this, your hour needle, your minute needle, your seconds needle, all like this. This will be rotating continuously. On the other hand, if it is going to be a digital clock like this is a digital clock. When it is going to be a digital clock like this, it will trigger only at an instant. Impulse. So that is called as impulse. It will be giving operation only when impulse. So for example, kid is there, na? If always you make it sit like this, it will be sitting like this. You immediately pinch. So our mother, if he's sleeping, so immediately during study, she will pinch or she'll just give a tap him like this. Immediately an impulse is given. So what he reacts, okay. So an impulse input or a impulsively, if it reacts, so digital. So that will be represented. So some might know, some might not know. Many will have come across only this type of d squared x by dx squared. For continuous equations you would have come, but when like digital clocks, digital like Apple phones or Apple watches, if you see now, all are digital in nature. Currently everything is digital now. So digital, when it goes to digital, they represent it by means of what equations called as difference equations. So see here it is differential equations, continuously varying with time. A mill, a loom machine, a jet. Okay, so there are many types of textile loom machines. So for example, weaving mills, continuously 24 hours the machine is running. Okay, how much heat it would generate? So continuously running, continuously the system is operating. You're without your laptop, you're operating your laptop without shutdown for 24 hours. Okay, your server, a big server, for example, for the entire office of a Wipro or a CTS, the server will be operating 24 hours per year. So the server is continuous. So when a system is continuous, you will represent it by means of differential equations. But when the system triggers at impulse reactions, then you use what called as difference equations. Why I talk about this? See, because if soft computing, why soft computing came, before soft computing or what goes hard computing or so when I have a differential equation, like this, d squared x by dt squared plus 5 dx by dt plus 7x. So what is the transform I have applied? I want to find solution to this equation. I told you starting, what is the ultimate aim? Problem solving. Why won't you solve the problem? Because I'm always given a problem. That is my, so you are given a task and you have to execute a task. In other words, it can be called as problem solving. I want to find solutions to the problem. So if I want to find the solution to this problem, here I use what called as Laplace transform. Okay, Laplace is a Russian mathematician. Okay, so he's a Russian mathematician. Laplace. So you apply Laplace transform. So we have still not got for this s squared x of s plus 5 sx of s. So like this, when it is going to be difference equations, so all apples, all your mobile, many things operate on difference equation methods. So how they call it, instead of dx by d squared x by dt squared or dx by dt, they call it as 5 into x minus 2. This x can be any parameter of your application, a frequency of a wireless networks, in a congestion control, number of packets, number of waiting time, number of packets that got delivered. So like that. So 9 into x minus 1 plus 7x, so will be equal to 10u, for example. Here, if I want to find difference equation. See, I can apply Laplace transform only if I have this equation. This is a second order equation. Okay, 2, it is 2, hence it is second order equation. If I want to apply Laplace transform, I want this equation. Now here, difference equation, all digital technologies will be operating back-end in programs. Programs will be using difference equation. We will not know in terms of microprocessor, in type of microcontrollers, in type of PIC, in type of DSP processors. Inside a DSP processor, IoT enabled, all DSP processors will be there. All DSP processors or VLSI processors, everything will be operating only on difference equations. Will be operating on difference equations. If I want to solve this difference equation, I go for Z transform. I go for Fourier transform. I go for fast Fourier transform. I go for infinite fast Fourier transform. I go for wavelet transform. I go for wavelet transform, etc., etc. Okay, but when can I apply Laplace transform? Only if I have a differential equation. For example, my problem has multi inputs, multi outputs. Whether a single differential equation is sufficient to describe my system? No, I have 100 differential equation. I have 100 differential equation. For the 100 differential equation, there might be a differential equation of d to the power 25. D to the power 25 I can have. Okay, so 100 differential equations is going to represent a system. How much time it is going to solve the problem? How much time I will apply Laplace transform? Then I will apply inverse Laplace transform. In a similar way, when it is going to be DSP processors, when it is going to be VLSI chips, okay, whether it is low power VLSI or whether it is going to be other types where processor embedded chips are going to be there, system on chip design, SoC. Okay, so like system on chip design is going to be there. Everything will be operating in difference equation. So this is very, very important. Difference equation in this digital era, difference equations are very, very important. And to solve this difference equations, you need Z transforms, Fourier transforms, wavelet transform. These will be embedded in the chip. The system on chip design, this will be embedded in the chip. But I can apply all these transforms, Z transform, Fourier transform, discrete cosine transform, DCT, DFT, discrete Fourier transform. All these transforms, wavelet transforms, only if I have this difference equation. Now, with the complexity, I told you, the complexity word, with the complexity increasing, with the data increasing, and I'm able to write a differential equation, and I'm able to write a difference equation only if I know a relation between input and output. Okay, so remember, only if you know relation, between, I told you, a system. There will be no system in the world without input and output. There is no system in the world without input and output. There is always a relation between the input and, only if you know, okay, there is a system with input and output. Only if you know relation between input and output, you can write the mathematical model of a system. Okay, a system, arrangement of physical components. Any system will have input and output. Any system don't have only single input and single output. Any system will have multiple input and multiple output. And only if the relation between the inputs and outputs are known, if number of packets delivered is known only, I can calculate the waiting time of the other packets or how to send the other packets. If all the packets goes there and it gets congested, network traffic will occur. So only if I know the relation between input and output, I can write an equation. See, always physics, we start with V is equal to IR. I am basically an electrical engineer, so always I start with V is equal to IR, Ohm's law. Okay, so Ohm's law, see, always the voltage is the product of this. So relation between input, if I know what is the current which is flowing through the circuit, if I always know the current which is flowing through the circuit, so this is resistance and here it is the voltage, I can calculate it. So now what happens, only if I know the relation between the voltage, current and the resistance, I write it as V is equal to IR, or speed or efficiency. Efficiency is equal to output by input. Only I know what is the relation between input and output, I can calculate the efficiency. Otherwise, I cannot calculate the efficiency. So only if I know the relation between input and output, I can obtain the mathematical model, which is called as a mathematical model. This differential equation is called as a mathematical model. This difference equation. So when you read an IEEE paper, an ASEAN paper, an Elsevier paper, a Springer paper, so whatever it is, American Society papers, so they'll tell mathematical model. Okay, you will go and tell, okay, it is a mathematical. Hey, what is a mathematical model? A mathematical model, it is a relation between input and output. Okay, so it's a relation between input and output. Hey, how do they represent a mathematical model? A mathematical model can be represented as a differential equation, can be represented as a difference equation. Oh, okay. Now I have got the mathematical model. Now, how to solve the mathematical model? Hey, the traditional computing techniques or hard computing techniques or transforms. So Laplace transform is a traditional approach. So I told you here, traditional approach, mathematical models, traditional approaches, mathematical models. Hey, what are the mathematical models? Relation between input and output is called as mathematical models. Relation between input and output, black box models. These are black box models. These are black box models. Always there is a flight crash. Now China, very pathetic. I think you have heard of now. So 10 days back or weeks back, there was a flight crash and 132 passengers on site. There was casualty. So then they'll search for black box in the flight. What is black box? What is black box? So a black box will, at what point the failure occurs, that black box will locate the latitude, longitude, altitude point. So if you are able to locate the black box, then we can find at what altitude it has fallen, and you can go and search for persons. Then you can go for search for persons. So any doubts? I am on the screen. I am audible. Someone is. Sir, your voice is not clear. Professor Narayana Rao. Professor Narayana Rao has raised a hand. You can give it in chat box also. Professor Narayana Rao. Okay, so he's not responding.
Sorry, ma'am. It's by mistake it is press the page. Sorry for inconvenience, ma'am.
No problem. Okay. So if you see, traditional, okay, so I was telling about traditional. So you should have a relation between inputs and outputs, then only you can go for mathematical models. So when complexity of the data increases, for example, I have 1 lakh data. I have 10 lakh outputs. I want 10 lakh outputs from 1 lakh. Text mining, web mining, data mining. For example, a big loom machines. Okay, so it has to render. It has to render, and this I am. So when they find, we cannot tell only because of the moisture level or because of the wind speed only the flight got crash. Can you tell only one parameter is responsible? Only that parameter has influenced for the flight crash? No, we cannot tell. We cannot tell that only one parameter. So hence, when complexity of the problem increases, when complexity of the data increases, when voluminous of the data increases, we cannot use if you don't know, I'm a fresher. I don't know anything about that research problem. Not research problem. You want to do some small startup. You want to do a mini small startup. So I don't know any knowledge about when we start our thing. So we don't know what is that. When I started learning soft computing, I don't know what is soft computing. So I started from the scratch. So when the problem is started from the scratch, we don't know the relation between input and output. When you don't know the relation between input and output, you cannot define the differential equation or difference equations. So in that scenario, you cannot apply your traditional techniques called as transforms, or these are also called as linear programming. Many work research thesis, machine learning, deep learning, neural networks, backpropagation neural network, radial basis function neural network, perceptron, deep learning, convolutional neural network, VGG16 architecture, etc. But I asked them a simple question. Hey, why for your application you have used this? This can be solved even by a simple linear programming technique. Why have you used neural network? No, ma'am, everyone tried to use neural network. I also used neural network. That is not the way. That is not the way. If for your problem, you are able to get it differential equation. You know the relation between input and output. You know a relation, and it is not of higher order, d squared x, d cube, till d power 10. Okay, you can solve. If more data, voluminous of data increases, handling images, MRI, brain images, no, when you go take an MRI scan, they'll give some big bunch of cover, they give. You take more voluminous of data. I want to take for 10,000 patients data. I want to handle for diabetic diagnosis, Alzheimer diagnosis, or autism. When data is increasing, I want to forecast the energy, solar energy, wind energy for entire India. The data is very high, each district. So if you take Arunachal, Pasigat, if you take wind, the force of wind is very high. So it will be better to generate. But it is very difficult to construct the windmill. Okay, but whereas in our case now, so in Udumalpet or Palladam area, in Thoothukudi zone, it is very possible, Tuticorin area, it is possible to construct the windmill. But here now, even though wind speed is very immense than Palladam or Udumalpet or Thoothukudi, but here it is very difficult. So okay, so like that, what happens? So for that handling data, complexity of the data, no equations are there. When traditional techniques are not able to be used, then you go for what called as soft computing. Okay, then you go what called as soft computing. So hence, so remember, this is very, very important. This is very, very important. So any system, I have hundreds of data, input and output. There is no relationship between the input and output. I am not able to write the mathematical model. So what is a mathematical model? Differential equations, difference equation. That is mathematical model. Okay, so in any paper you find mathematical model, hereafter you should remember it as differential equations. Only if you know the mathematical model, you can apply all these traditional techniques called as transforms. Z transform, Laplace transform, Fourier transform, wavelet transform, etc., or your linear programming techniques like Gauss-Seidel elimination, Gauss-Seidel techniques. All these are called as linear programming. All these are called as linear programming, stochastic linear programming, non-linear programming also. There are few like gradient methods. They also can be used. Variable gradient methods are there. So when all these methods are not to be able to be used for your problem, then I have data. I have voluminous of data. The size of data is very high. The complexity of the data is very high. The complexity of the data is very high. So, and there is no relation between, I don't know a relation between input and output. I don't know relation between input and output. I don't know relation between input and output. And since I don't know the relation between input and output, I don't have a mathematical model. If I don't have mathematical model, I cannot apply my traditional techniques or conventional techniques, or black box techniques. So, but generally they don't call it as black box. It is traditional techniques. I cannot apply conventional techniques. So what to apply? Go for soft computing techniques. Why soft computing? Go for soft computing because soft computing can handle any voluminous of data. Soft computing can handle any uncertainty, fuzziness, okay, any uncertainty, any complexity, because it is based on human learning process. How humans learn? The power of brain the human has. So because why it is able to handle voluminous of data, how complexity can be handled? Human learning. How human learn, how human makes a decision process, how you make a decision, and how human evolution has come. 3 categories. Only these 3 categories of human mechanism, how humans think, how humans work, how human brain operates, are the fundamental ways of developing a soft computing algorithm. So I don't want a relation between input and output. I don't want a mathematical model. I just data is enough. You want any problem? Some company is coming, some green energy. Green energy systems is there. For renewable energy, it wants to do wind prediction or solar prediction. What is the power of the photovoltaic cell? Can you use soft computing? Yes, we'll forecast. We will study the past 10-year data, electricity price increasing, fuel price increasing, stock market price increasing, related to Google also, related to image handling, data handling, images. See, nowadays now, if you see, image processing has taken a very wide, anything, all you shoot photos, images, screenshots in your mobile, so much image voluminous, any soft computing. Deep learning can handle any types of techniques. So this is why soft computing. Okay, why soft computing? Do you have any doubts? So this is hard computing. It requires exact and accurate data. Okay, so another important thing of soft computing is it requires hard computing is it requires exact data. So I see, for example, I'm giving you a small information. Now the outside temperature is 19 degrees Celsius. The humidity in the air is 5 milligram, and the moisture content in the air is 0.5 grams. Okay, now I am asking you whether rain will come or not. See here, I have given you exact answers. So I'm giving you exact values. Okay, so the temperature is 19 degrees Celsius. Temperature is 19 degrees Celsius. Humidity in the air is 5 grams. Moisture content in the air is 0.5 milligrams. Now I'm giving accurate values. Now I'm giving you accurate values. Hard computing, all your difference equations requires accurate value. Now I'm giving you accurate value. I'm asking you an answer whether rain, for this accurate data, rain will come or not. What is your answer? What is your answer? Whether rain will come or not? May or may not. No, I don't. I'm giving you exact values. Na? I'm giving you accurate values, Mr. Pulkesi. I'm giving you exact values. I want an exact answer. Now I'm asking you. The sky is cloudy. The sky is cloudy. You feel the smell of the sand. Now whether you will see what is your temperature, your moisture, humidity, will you see? Or what will you do? Or what will you do? Rain will come. Yes. Yeah, membership functional will not go to the higher level of it. Okay. Rain will come sure. Yes. Narayana Rao sir also has told. So see, now problems like this, when even accurate values are given, you are not able to give a solution. But you are given uncertain data, cloudy. Don't know. You can't define cloudiness. How do you define the cloudiness? Smell of sand. How do you define smell of sand? Any metric is there? No. You feel it. Human brain, human decision. You are trained. Your brain is trained for that. So training. Your brain is trained. Okay, your mother, father, grandfather. Hey, no. See, cloudy, na. You feel smell of sand. Get inside. Don't train. You're used. So your training, learning process. So just simple if rules, if then rules. So like that now. So hence I want you to tell, even though the input is accurate, your traditional methods even may fail to give you a solution. On the other hand, so the power of the brain, even with uncertain data, it can give you a perfect solution. So hence what happens here. So all these soft computing techniques, so a system, I said you, input variables will be there, output variables will be there. So hence always your soft computing techniques, how humans, so you teach your child, so how you have trained your brain. So when I'm asking you again a question, so A to Z is how many letters? A to Z? Sorry, it's a very big audience gathering. I should not ask. So it is 26 letters. Have you asked when you are a kid? Have you asked why it is not 20 letters or why it is not 32 letters? Did your brain ask that? Now, if at the end of the session, they said, no, this Deepa ma'am came something, she delivered a soft computing, we didn't understand. Your brain is a trained brain. Your brain is capable of associating. Your brain is capable of classifying. Based on the classification, you're able to make a judgment whether this lecture session is good, whether lecture session is not good. You're able to justify it. So, but when you're small brain, when you are taught A to Z is only 26 letters, you accepted A to Z as 26 letters. A is this? Yes. A is this. A is this? Yes. A is only this. So like this, you have accepted. So hence, your brain, you have modeled all those algorithms. So when you have modeled all those algorithms into the brain, so that will be called as neural algorithms. Okay, so that will be called as, so the main constituents of your fuzzy modeling will be your soft computing model will be fuzzy systems, rule based decision making. It will be rule based, right? So it will be rule based, and neural networks. Your brain, your learning process. How do you train a kid? A to Z rhymes. They tell rainy rain, go away, come again. So their brain is trained. So then they ask the child, repeat it. It repeats it. Its brain is trained for that. Okay, 1 2 3, 1 plus 1 is equal to 2, 1 in the hand, 1 in the brain. Learning. So learning process. So you devise algorithms, you design algorithms based on your human brain. You formulate what called as neural networks. You formulate what called as neural networks based on your evolution, how your evolution has been there. Okay, Charles Darwin's theory of evolution concept, you bring into algorithms, you call it as evolutionary computing. Okay, so your fuzzy systems for handling any type of imprecise data, uncertain data, fuzzy data, vague data. The data is very vague. I don't know what to do with this data. You've been given a task. Okay, why are you suffering? Go for fuzzy systems. It will give you a solution. Learning how, see, the CNC machines, now it is not operating. I want to make the CNC machine tune. Yeah, go for computational methods to train by itself. If the coolant is getting heat over 100 degrees Celsius, let the coolant be moved out of the machine. So it is a learning process. When uncertainty is there, if it is not specific, then you go for probabilistic optimization. See, you want an optimal solution. Nowadays, all the searches going towards optimization. See, I have a cloth. I want, for summer season, cotton clothes is the best. For winter season, woolen clothes is the best. But I cannot design a wardrobe for summer season and winter season. I want to design a wardrobe on optimal. I want a cloth which I can wear in summer season, rainy season, autumn season, spring season, any season. So optimization, I want to find optimal solution, but I don't have a mathematical model. I cannot use Z transform, Laplace transform. Then what should I do? In soft computing, there is a process called as evolutionary computing. You go for that. So framework of soft computing, fuzzy logic, neural network, evolutionary computing. It started with genetic algorithm. So the professor was Holland. John Holland was the professor who started to work with genetic algorithm. So Holland was followed by Goldberg. So, and they started, the first problem where evolutionary computation was applied was in US. It was applied for a civil engineering problem. If you see, what is that civil engineering problem? They want to construct a bridge. The bridge, they don't get bricks, single. They can't get bricks. So they wanted to evaluate, you cannot, it has to be strong, number of bricks required for construction of a bridge. I think Caltech professors, California University, I think so. Okay, you can refer. Okay, so for construction of bridge, that was optimal number of bricks required for construction of bridge. So evolutionary computing. So one of the evolutionary computing is GA was used, which was used by few Caltech professors, I think. So, but it was started with Holland only. Okay, mostly initial days, this evolutionary computing was mostly applied for all truss problem, calculation of truss in engineering mechanics, many things civil problems only it started. Evolutionary computing was appeared. So see, if you see traditional computing or hard computing, these methods are not user friendly. Like mathematics fully, see, mathematics, it has to go hand in hand. But when the order of the polynomial, when the order of the differential equation, when the order of the difference equation increases, the time complexity also increases, and the accuracy of attaining the problem and calculating and evolving a solution is very tedious. It is very tedious. But on the other hand, I have only data. Yes, for soft computing techniques, data is sufficient. Let it be millions of data. Will the process? Yes, you can devise the algorithm. It would be sufficient. So internet, HTTP, airlines, VLSI, biological, everyone, you can use it. Okay, so actually soft computing, or this was Zade. Lotfier Zade was the professor behind this. So I've learned so much about Zade out of interest of soft computing. Because why? Because always complexity increases. Any data nowadays, if you, I am operating with some energy related works. I'm operating with medical image data. So it's currently my work. If you see few works I'm doing with lung images after this COVID. So if you see, the complexity is always there, extracting some features or segmenting it and classifying it for any types of any diseases, for example. So what happens, the complexity is there. I have felt the complexity in the problem. So when you go into the depth, you could feel the complexity of the problem. So hence, in that case, Zade has given how human learning is being done. The devise an algorithm. Okay, how you train the algorithm, how you test. So how we are tested by exam mode. So you are trained 5 units. Your training is done for 5 units in the syllabus. First unit, second unit, third unit, fourth unit, fifth unit, your training is done. And what happens after the training is done? So your testing process comes. What is your testing process? Exam hall, okay, exam question paper. So you perform in the exam, your goal, okay, your goal is to get 90, okay? But your performance in the exam, you got only, so you have trained all the 5 units, training is completed. So testing mechanism, testing is your question paper, is your testing mechanism. So you perform in the testing, in the exam you perform, and your output comes. So your desired, your output or your goal is going to be 90, but your performance is only 70. The difference between the goal and the performance is 20. This is called as error. And your neural network algorithm is trained to reduce this error to 0. That's all is neural network. You carry out the training. You think your training is completed. All the 5 units I'm thorough? Yeah, I'm fine with all the thorough. Okay, then go for testing. Training is completed. After the training is completed, you go for another process called as testing. In testing, you have receive a question paper, you perform in the test, you get an output, okay? So you get an output, that is calculated output. So you get it as 70, 60 or 80 also, but your goal is 100 or something. So the difference between the goal and the performance, or difference between the desired target and the calculated output, is the error. Again, neural network has to be trained. A child has to be trained. If he wants to take some competitive exams, he has to reduce the errors. So his brain is trained for the competitive exams, right? So what happens? The error has to be reduced. So this concept of training and testing and learning by means of supervised learning or unsupervised learning, so this is called as neural networks. Yes. So see, it started. So it is even, it's very, we are speaking in 2020. It has evolved during 1940s. So interconnections in brain. So learning process, supervised process, unsupervised process. I cannot go into depth with it, lack of time. It's already over time we are going. So these are various architectures. So like how neurons are connected. You design neural algorithms like this, right? So these are operations. So see this fuzzy decision making. I told you, temperature is given, humidity is given, moisture is given, but you're not able to give solution. But you if then rules. If it is cloudy and If it is a smell of sand is there, then it is. So decision making. Fuzzy uses all fuzzy Omron. This is in Japan. So if you see all fuzzy rules, if then rules, if this then this, if this. So how do you write the rules? How do you write the rules? Yes, expertise in the field. Okay. Initially, you start with trial and error. Then you will ask, why are you starting with trial and error? You feel all this randomness is there, trial and error is there. Then how the model will be accurate? In hard computing, everything is accurate. So output is accurate. But in soft computing, randomness is there, trial and error is there. Then how do you say accuracy is there? Humans, initially you have your own trial and errors. So all these soft computing reasoning is based on human reasoning methods. So hence, yes, to start up, randomness will be there, but over a period with the expertise, with the learning mechanism, with the supervised, unsupervised reinforcement learning mechanisms, the randomness will be suitably handled so as to reduce the error values, and the network for the designed applications becomes accurate. Okay, so when you go depth into the problem, you will this. So either way, it can be combined. Neural fuzzy can be combined, neural this can be combined. So what are the advantages? If you see, they are simple, fast when computing, good in practice. So these are some intelligent control or soft computing controllers for submarines, for robotics. So this is a robo, na? So robo. So these are all higher end applications. So even for simple applications, washing machines, in cement industries, like, or in cars, na? Nowadays all cars are AI based. Artificial intelligence, there are neural algorithms in it, na? Because if the what to say, the back, so when you put reverse gear, na, so if you can see the image on your car, na? So on the screen in the dashboard of your car. Okay, so these are all algorithms. So these are all expert systems or artificial intelligence, all these stuff. So these are some robots, like robots which is used, and it is used everywhere. It is used, soft computing used in statistics, social sciences, behavioral sciences, even biology, medicine, engineering, science, as I said, in STEAM. Okay, science, technology, engineering, agriculture, and management. So everything will cover here in STEAM. So it has been used everywhere. But whether completely soft computing, see, initial preliminary, you can start with conventional methods because you should know the application better. Okay, you should know the application better. So when conventional methods and soft computing are combined, they call it as memtic computing. Okay, memtic algorithms. So you can come across what called as memtic. So memtic algorithms. So combining the traditional and soft computing is called as memtic computing. So it can be used. I will not tell Laplace transform is the worst, only soft computing is the best. Yes, Laplace transform is the best. Some problems, Laplace transforms gives a beautiful solution. Okay, some nonlinear system analysis and design, or design of certain filters, transforms give, DCT will give you a better solution. Okay, Fourier transform will give you a better solution. In that case, my neural network might fail. In filter design, sometimes noise may not be removed, but whereas a DCT, a discrete cosine transform, can perform a better operation, perform a better operation. So hence, it is better to use this. So my title on soft computing is Principles of Soft Computing, which is with Wiley. Okay, so if the webinar topic is soft computing, why? Okay, so what, when, and how, I have completed why, because I want to emphasize more on why, because everyone are using machine learning, deep learning, expert systems, evolutionary strategies, but they don't know why they are using. Okay, so now you should know, very important. You can learn what is what, how to use. There are many YouTube videos, Google it. You can find many resource materials, and you can go for NPTEL materials are there. If you see this, my book title, it is 3rd edition revised, and it is with Wiley. It contains all the algorithms, all the neural algorithms, latest algorithms, all the fuzzy algorithms, all the evolutionary computing. It comes with a CD. In the CD, now we have given all, nearly 10, 12 projects are given. The projects are given with coding, and all the, for each chapter, PowerPoint presentation is made, and that PowerPoint presentation is in that CD. And in this book, there are all MATLAB codings for each neural algorithm is there. That soft copy is also present in the CD. So this is my this is one of the title with Wiley. If you see, it has 26 chapters. Okay, so first chapter is the introduction chapter, then artificial neural network introduction, supervised learning networks, associative memory networks, third generation neural networks. So all the stuff, membership function, defuzzifications, fuzzy cognitive maps, genetic algorithms, differential evolution, and MATLAB experiments, and question papers for student point of view, but it can be used for research point of view, for MTech, PhD, BTech students also. They have started having it as a compulsory electives. It has come, and it goes. These are few references. You can always refer to Wasserman for neural networks, but Costco is good. I started learning with Fawcett, Lauren Fawcett. I have read many of Zade's papers. Okay, Zade. Okay, he's called as father of soft computing, Zade. So you start learning his papers, you will get automatically this. So so it is great reading his papers, Zade. So he is like that. So thank you. And I have received many questions now. When registering participants has asked several questions, but if you see now, so all were like mostly general questions. Yes, it can be used in healthcare. I'll send the PPT of this to the organizers. They will send it to you. Like this, whether mathematical model it is better. So it goes hand in hand. Is there any connecting mathematical principles in soft computing? Okay, so the session is interesting. Okay, oh, thank you, Mr. Pulakeza. So any questions, any more specific questions? Now the forum is open for discussion.
Thank you, ma'am.
Yeah,
Thank you for
thank
your
you, Dr. Akila. Yeah,
and
thank you, Ms. Nirmala. See, like you can work more projects proposals. Deep learning is getting this, so you can work on. So you can in this textbook. No, you have all the materials. You're a fresher. I don't know anything about soft computing. I don't know to do the coding, etc. You can just check this book. Okay, so my title of Principles of Soft Computing with Wiley. If you check out, you can. It will be very helpful to you all, and you can. You can give it to your students. If you're professors now, you can give it to your students as well. Yeah. Thank you, Abdul. Thank you, Mari. So any specific questions, my dear participants?
there are
Okay.
some questions given in Excel itself, ma'am.
Yeah, I saw that.
Yeah.
I saw that, but it is all not, it's all very elaborate only. If they have asked whether this can be applied for that. Yes, whatever they have asked, it can be applied. They've asked for few applications. No? So like that all we can apply. It's not a problem.
One person has asked, can you name few corresponding quality journals for publications in this
Journal
soft
publications. Yeah,
Yes.
I will give it in chat box. No? See, I refer always now. So someone you can check it in Taylor and Francis also. There are some journals in Taylor and Francis. Okay, so Taylor and Francis also it is there. So what I tell, yes, can we connect soft computing with networks? Sure. Many application for even QoS routing, etc. You can use soft computing techniques. That's not a problem, Abdul. So you can use like that. So there are several even InterScience journals are there. Taylor and Francis and Wiley also. So if you see few in Wiley also you have this methods, you can just refer to that. Okay. Any other doubts?
One more question in the
Yes, ma'am, please.
what is the role of soft computing in our daily life?
See, in our daily life now, so if you see in your daily life, if data is involved only, we have operation for soft computing. Otherwise, our learning process itself involves algorithms. Our learning, see, human learning process itself is a soft computing method. So, like, because as humans, no, so you train yourself. So our learning process, your washing machines, you operate with fuzzy, because like low speed, high, and if you see now your air conditioning systems, no, so it uses fuzzy. Like that, but optimality, it comes into only algorithmic modeling. Only fuzzy related daily basis, you're operating only with fuzzy systems, rather than neural networks and neural networks or evolutionary computing. Soft computing includes nano computing, ma'am. No. Nano computing is totally different. No? It is miniature chips, right? Nano is totally different from soft computing. Nano operates more specifically. Nano chips, no? So transistors are being replaced by nano devices. So it is like hard computing. Nano computing is not soft computing. No way it is related to soft computing. Soft computing and nano computing are completely diversified areas. Nano has to be accurate. Nano chip, you embed a nano chip in your heart, something like that. It is very accurate. Okay. If your faculty need complimentary copy, please write us. Yeah. See, Shri Deepak Saxena, sir of Wiley, has given you a comment in the chat box. If you're a faculty and need complimentary copy of my book, na, you write to them, they will send it to you. Okay. So you can note that mail ID. Okay, so now if no further queries, na, I would like to take this opportunity to thank Dr. P. Sakthivel. So he was the chair of IEEE Computational Society of Madras section. Dr. Priya Vijay, the vice chair of this IEEE Computer Society. Mr. H.R. Mohan. Dr. Akila for being very patient, and she has contacted me and sent mails, and she has created all the groups, and she has always been very dynamic in organizing this event. So Mr. Deepak Saxena of Wiley. So always I have a long time bonding with Wiley. So hence in this case, so it is thank you the entire Wiley team, and specific thanks to Deepak Saxena and everyone, my dear participants. Okay, so I was very much worried now about my internet connectivity. So thanks to the Almighty. Okay, so for making this webinar possible. You can mail me at you can because my if my NIT mail ID, you send it from Gmail, it will not come. You can mail to this mail ID. Any specific queries, you can mail me to sndeepapsg@gmail.com. I would reply, not immediately, but surely I'll be giving a reply. Okay. So, Dr. Akila, thank you so much. Am I done?
Yes, please.
Yeah. So, thank you, dear participants. Shall I leave the meeting? Deepak Saxena, sir?
Ma'am, we will have some formal vote of thanks from our side.
Oh, okay, ma'am. Okay, ma'am, please.
Good evening, everyone. So, I thank everyone for attending this seminar, soft computing, what, why, when. I thank Deepa, Professor Deepa ma'am, for her simple statements, clear explanations about why soft computing. Thank you so much, ma'am. I thank our associate partners, IEEE and ACM, for associating with us and helping us to continue with the seminars throughout the year. I thank HR Mohan sir and Dr. P. Sakthivel sir for associating with me for these past long years, for arranging the webinars and associating with Computer Society of India. I thank Vijay, Mr. Deepak Saxena and his team for associating with us and helping us for arranging webinars, publishing book with us, and also providing one book chapters to our participants and members. I thank our event management team, Dr. Agila, MC member, and Mr. P.V. Subramaniam, past chair, for helping us to provide all event management facilities, starting from invitation till sending video edited recordings. I thank all the members, past and present members, OB members of IEEE ACM, and CSI for participating in the webinar. And I also thank all the webinar participants who have been enthusiastically participating and also interacting with our eminent speaker. Thank you all. Take care. Good night.
Thank you. Thank you, Ananda.
Thank you, ma'am.
Thank you.
Thank you, Deepa ma'am. Thank you, Mohan sir. Thank you very much.
Thank you all.
Thank you, sir. Thank you, Deepa ma'am.